In this video, we are going to look at representing inequalities on the Cartesian plane. So first, I have draw the graph of y is equal to 3. Now, here I have my Cartesian plane consists of my x-axis and y-axis. Now you can see the y-axis is the vertical line or the vertical axis. So I look for 3 on the y-axis since its y is equal to 3. And I draw a horizontal line, a solid horizontal line passing through 3 on the y-axis. And this will be the graph of y is equal to 3. Now this is an equation because we have an equal sign. So now let's use the inequality sign. So now we're going to represent y is less than or equal to 3 on the Cartesian plane. So first, I will look at my y-axis. I'll look for 3 on the y-axis and I'll draw a solid horizontal line passing through 3, and this line will be called our boundary line. So there you have it, our boundary line, y is equal to 3. Now, when we look at our boundary line, we want y is less than or equal to 3. So we look at the y-axis and determine which values are more than 3 and which values are less than 3. So 4, 5 on the y-axis will be more than 3, but 2, 1, 0 will be less than 3. And that's why we shade in below the line. Because going below the line, below y is equal to 3, would be y is less than 3. And the line is solid to represent y is less than or equal to 3. If it was y was less than 3, this boundary line would have been a dotted line. So below here we have y is less than or equal to 3. Now if we come across here, we have represent y is less than 3 on the Cartesian plane. So again, for our boundary line, we're going to draw a horizontal line passing through 3 on the y-axis. But this time is y is less than 3, is not equal to 3, it's just less than 3. And that's why our boundary line, it's a dotted line. And of course, we shade below the line because that's representing y is less than 3. So below the line is y is less than 3. And of course, our boundary line is y is equal to 3. Now if we come across here, we have represent y is greater than 3 on the Cartesian plane. So again, we draw a horizontal line passing through 3 on the y-axis. And because it's just y is greater than 3, it's a dotted line. If it was y was greater than or equal to 3, the boundary line would have been a solid line. And of course, greater than 3 on the y-axis would be above 3, like 4, 5, 6 on the y-axis. Those numbers are greater than 3. And that's why we shade above the line. So this region would be y is greater than 3. And of course, because it's just greater than 3, the line is dotted. So our boundary line would still be y is equal to 3 as our boundary line. So now if I was to convert this to y is greater than or equal to 3, so I'm going to put this here, y is greater than or equal to 3, our boundary line will turn from a dotted line into a solid line. And now this will represent y is greater than or equal to 3. So for this one, we have draw the graph of x is equal to 3. So again, we have our Cartesian plane, our x-axis or y-axis. And since it's x is equal to 3, we look for 3 on the x-axis, that's right here. And we draw a vertical line, a solid vertical line, passing through 3 on the x-axis. So this is an equation. Now for the inequality, we have represent the graph of x is less than or equal to 3 on the Cartesian plane. So again, we'll draw our boundary line, which will be x is equal to 3. So this here is x is equal to 3, and this is our boundary line. Then looking at the x-axis, we determine what is greater than 3 or what is less than 3. So since x is less than or equal to 3, our boundary line is solid. We know it was x was less than 3, the boundary line would have been dotted. And since it's less than 3, 4, 5 is more than 3, so it's not the side. But 2, 1, see we're looking at the x-axis, right? So 4, 5 on the x-axis, more than 3. But 2, 1, 0 on the x-axis, that's less than 3. So that's why we shade the left-hand side of the boundary line. So on this side would be x is less than or equal to 3. So moving on here, we want to represent x is less than 3 on the Cartesian plane. So again, our boundary line will be a vertical dotted line, which we have here, passing through 3 on the x-axis. So we have x is equal to 3. This is our boundary line. And it's dotted because it's just x is less than 3. And again, less than 3 means, looking at the x-axis, we have 2, 1, 0. That's less than 3. So we shade in this side of the x-axis, which is the left-hand side. So on this side, we have x is less than 3. That's our shaded region. Now, if we want to represent x is more than 3 on the Cartesian plane, again, our boundary line would be dotted, a vertical line passing through 3 on the x-axis. So again, x is equal to 3 is our boundary line. And more than 3 on the x-axis would be 4, 5, 6. And that's why we are shading the right-hand side of our boundary line. So here would be x is greater than 3. Now again, if we wanted to convert this to x is greater than or equal to 3, we would convert our boundary line from being dotted into a solid line. And now that the boundary line is solid, the shaded region will represent x is greater than or equal to 3. So now let's look at this question. We have part A here. Draw the graph of 3x take away 8y is equal to 24. So how do we do that? Well, we can do it in two ways. We can put this in the form y is equal to mx plus c, get the gradient and the y-intercept and sketch the graph from that. Or we could find the x and y-intercepts and draw the line from that. So today I'm choosing the method of finding the x-intercept and the y-intercept and drawing the straight line. Alright, so question 9 part A. To find x-intercept, let y equal 0. So we have 3x take away 8y is equal to 24. We're going to replace the y with 0, so that's 3x take away 8 times 0, because y is equal to 0. Of course, anything multiplied by 0 is 0, so 8 times 0 is nothing. So we have 3x. I mean, I don't have to write anything, okay? 8 times 0 is nothing, but I still put take away 0. All those zeros need a positive or negative, that's why we just write nothing. So now we'll have 3x is equal to 24. Now we transfer the 3 across equal sign. Since we have 3 multiplied by x, so we transfer it across, we'll turn to division. Or you can say divide both sides by 3. So we have x is equal to 24 divided by 3, which is equal to 8. So essentially the coordinates of the x-intercept would be 8 on the x-axis and 0 on the y-axis. So let's put x-intercept would be 8, 0. Now I'll put to find the y-intercept. We'll put x is equal to 0. So we'll have 3x take away 8y is equal to 24. So replacing the x with 0, we have 3 times 0 take away 8y is equal to 24. Of course, anything multiplied by 0 is 0, so 3 times 0 is 0. I didn't have to write anything, but I'll still put 0. Take away 8y is equal to 24. So now we have negative 8y is equal to 24. So now I could transfer the negative 8 across the equal sign and get 24 divided by negative 8. Or I could say divide both sides by negative 8. So we get y is equal to 24 divided by negative 8. And of course, 24 divided by negative 8 is negative 3. So y is equal to negative 3. So our y-intercept would be 0 on the x and negative 3 on the y. So y-intercept would be 0 on the x and negative 3 on the y. So here I have the x-intercept that I worked out, the y-intercept that I also worked out. I have my Cartesian plane, consists of my x-axis and y-axis. So now let's plot our x-intercept and our y-intercept. So our x-intercept is 8 on the x-axis and 0 on the y. So that's 8 on the x-axis and 0 on the y, that's right here. So let's plot this point here. 8 on the x-axis, and that's why I call it the x-intercept. That's where the line will touch the x-axis. Now notice this, in our working, we have x is equal to 8, and then I wrote the coordinates as 8, 0. 0 on the y, 8 on the x. But let's look at the answer right here. X is equal to 8. You're plotting the point at 8 on the x-axis. So 8 on the x-axis. Same thing for the y-intercept, we have 0, negative 3. So that's negative 3 on the y-axis. 0 on the x, but negative 3 on the y. So that's this point right here. And again, we could go back to the working, where we worked out the y-intercept. We got y is equal to negative 3. Of course, the coordinates would be 0 on the x and negative 3 on the y. The 0 from here, 0 on the x, negative 3 on the y. But you can just look at this answer right here. Y is equal to negative 3, and let's plot negative 3 on the y-axis, which is right here. Now, it's a straight line, so all we need is 2 points. And these are our 2 points here. We just take our ruler and connect these 2 points, making a straight line. And that will be our graph. All right, so here I have my ruler connecting the 2 points, and I'm about to draw my line. And this will be our graph of 3x take away 8y is equal to 24. Now for part B of this question, we have hence shade the region representing 3x take away 8y is less than or equal to 24. So because it's less than or equal to 24, we will keep this solid line. It would not be a dotted line because we have less than or equal to 24. Now to know if we're shading above the line or below the line, I'll need y to be the subject of the formula. So what I'm going to do, I'm going to take the 3x, take away 8y is less than or equal to 24. We're going to transpose y. So I'm going to transfer the positive 3x across the equal sign. I will turn to negative 3x. So we have negative 8y is less than or equal to 24 take away 3x. Now, this is an inequality. So when I'm transferring this negative 8 across the equal sign, essentially we are dividing both sides by negative 8. This inequality sign will have to switch around. Because positive 8y is less than or equal to 24 take away 3x. When I transfer the 8 across, the inequality sign would have remained the same. But because it's negative, we have to switch the inequality sign. So we'll have y is greater than or equal to 24 take away 3x over negative 8. So you see we transfer the negative 8 across. The operation changed from multiplication to division, so it went under. But because it was negative 8, the inequality sign has to switch around. So now that y is the subject, you can see that y must be greater than or equal to whatever on this side. Now, we're not too concerned with whatever on this side. All I'm interested in is if y is less than or equal to, or y is greater than or equal to. Now, seeing that it's greater than or equal to, I would shade above the line. If it was less than or equal to, I would shade below the line. So that's one way of looking at it. Now, another way of looking at it is, you see this line, it makes an angle with the x-axis. So this angle here would be an acute angle. So the acute angle, the side with the acute angle represents less than. And this side would form an obtuse angle. And the side with the obtuse angle will represent more than. Alright, so here I have it labeled obtuse angle here, obtuse angle with the x-axis, and here's the acute angle with the x-axis. So acute is always smaller than obtuse, so acute will be the less than, obtuse will be the more than. Now, seeing that we have y is more than or equal to, it will be on the side with the obtuse angle, which will be on this side here. So for the shading, we can just use some lines. I can just put some lines like this, and this will represent the shading. Now, what does this mean? It means any coordinate on this side of the line, which is above the line. If I take that coordinate, it has an x component and a y component, and I put it into this inequality, I will get a number that's less than or equal to 24. Let's check that. A simple point we see in here is the origin, which is 0, 0. So obviously, if you put 0, 0, 0 for x and 0 for y, it will be less than 24. So let's try something different, like here, 1, 1. So this will be our test point. So you're going to put a test point here, which is 1 on the x, 1 on the y. Okay, I'm just going to put testing. All right, using the point 1, 1. So that's 1 on the x, 1 on the y. We have 3x take away 8y is less than or equal to 24. So x is 1, y is 1. So that's 3 take away 8, because 3 by 1 is 3, 8 by 1 is 8. And 3 take away 8 is negative 5. So you have negative 5 is less than or equal to 24. And this statement is true. Negative 5 is less than or equal to 24. So again, with that little testing, you know you shade the right region. So let's choose any point on the side that you have shaded, get the coordinates, and just test it. And you know if you're correct or not. So again, transpose for y, and if it's more than, you shade above the line. If it's less than, you shade below the line. Or you can look at the angle that the line makes, your graph makes with your x-axis. The acute side would be less than, so below here would be less than because this is the side with the acute angle. And the obtuse angle, which is the bigger angle, would be the side for more than. So if it's more than, you shade the side with the obtuse angle, which is this side. And of course, to make sure you're right, you can just test a point. Test a point on the region that you shade and make sure that it's correct. And this could lead to another method to determine which side to shade. You could test a point above the line and you could test a point below the line and see which one is true and which one is false. Of course, the true one, the one that's true, like if we had tested this point and say, okay, this is true, we know this is the region that we have to shade and we shade above the line. If we test a point down here, we'll get a false result. So let's test and see if we get a false result. And we could take a point right here. This is 3 on the x and negative 4 on the y. So I'm just going to mark this off. And this is 3 on the x and negative 4 on the y. Let's test that and see. So we have 3 on the x and negative 4 on the y. So this is x, this is your y. So we have 3x take away 8y is less than or equal to 24. So we have 3 by 3 take away 8 by negative 4 is less than or equal to 24. So 3 3s are 9. Negative 8 by negative 4 is positive 32. Is less than or equal to 24. And 9 plus 32 is 41. So 41 is less than or equal to 24. And of course, this is false. So because of this false statement, this region down here is not the shaded region. So you see, I test a point below the line and it was false. That's why we're not shading below the line. I test a point above the line and it was true. And that's why I shade above the line. So that's another method you could use to determine which side of the line to shade. So for this question, we have to shade the region that represents 3x plus 8y is less than or equal to 24. So here I have my boundary line, which represents the graph of 3x plus 8y is equal to 24. So let's write that in. This is 3x plus 8y is equal to 24. So this is my boundary line. Of course, it's solid because we have less than or equal to. If it was just less than, it would have been a dotted line. And now we must determine whether we're going to shade below the line or above the line. So again, we have to transpose for y. So I'll have 3x plus 8y is less than or equal to 24. Transfer the positive 3x across the equal sign, we'll turn negative. So we have 8y is less than or equal to 24. Take away 3x. Then we transfer the positive 8 across, the operation changing from multiplication to division. So it will go under what's on this side, under the 24 take away 3x, which is 24 take away 3x divided by 8. Or we could say we divide both sides by positive 8. And we get y is less than or equal to 24 take away 3x divided by positive 8. Now notice the inequality did not change direction. That's because we had positive 8 going across, whereas in the last one we had negative 8 going across, which caused the change. So anytime you have to divide both sides of the inequality sign by a negative number or multiply both sides of the inequality sign by a negative number, the inequality sign needs to switch around. So now that we know y is less than or equal to, that's what we're interested in, y is less than or equal to, it will be on the side with the acute angle. So that's on this side here, so that's below the line. Again, you could look at it as y is less than is below the line. If y is more than, it's above the line. All right? So again, same thing. If it was y is more than, it will be the side with the obtuse angle. But since it's less than, it's the side with the acute angle. Or we could do the testing, right? Test a point above the line, test a point below the line, and see which one is true. Okay, so we'll be shading below the line. So let's take some lines like this. and this would represent your shading. And of course, we have shaded the region representing 3x plus 8y is less than or equal to 24. And before we go, just want to look at this same question. Shade the region 3x plus 8y is less than 24. So instead of less than or equal to 24, we just have less than 24. So same graph. So same boundary line, but the boundary line is dotted instead, and we shading below the line as we did in the previous question. So this is the previous question, we shade below the line, but the line was solid because we had less than or equal to 24. And this time we have a dotted line because it was just less than 24. But again, same thing, we shading below the line. And that will bring us to the end of this video.